The faster CPython project brings several significant speedups to Python 3.11. On a whole, these accelerate both interpreter startup and runtime. In particular, PEP 659 provides improvements to the Python interpreter that make several fundamental operations faster. Looking at Py performance, we see a wide range of speedups across the benchmark suite. On the left, we see the results published by the faster CPython team running on bare metal Ubuntu, which measured a mean speedup of 1.3. On the right, I compare this to my MacBook Pro running Python inside a Docker container, which yielded a less pronounced speedup of 1.2. If your workload consists of a lot of pure Python, you should expect to see a significant speedup when you upgrade to Python 3.11. Python 3.11 has another speed improvement, but is not measurable by the interpreter startup time or Py performance benchmarks. The addition of PEP 657 makes it way faster to figure out what's wrong with your Python code. Take a look at this error message from Python 3.10. Where is the division by zero error? Previously, we'd need to separate out these operations onto separate lines or print out the values of each variable to get to the root cause. But now, Python 3.11 will point us exactly to where the error occurred. Python 3.11 adds the addNote method to the base exception class. This makes it easier to add contextual information to our exceptions. Previously, this might be done like this. I think the new addNote syntax is way cleaner and easier to remember. With pyproject.toml emerging as the standard for Python packaging and configuration, Python 3.11 adds tomllib, a toml parser built into Python. To parse a toml file from disk, we can open the file as binary and use the tomllib.load command. This will parse the toml file into a Python dictionary. If you don't read the file as a byte string, you'll receive a helpful error message reminding you to do so. Alternatively, you can parse a toml formatted string using the tomllib.loads command. Unlike the tomllib.load command, this command only accepts a string, and it will provide a very unhelpful error if you provide it a byte string. It's also worth noting that tomllib only contains a parser, so it won't help you create toml files. Previously, if you wanted to type in an object that returns self and uses inheritance, Python's type system had a pretty large pitfall. The intuitive way of type hinting things would be to return the class of the object whose method returns self. Unfortunately, this doesn't work when using inheritance. If we call a method that returns the parent class, then the subclass's method will think it's receiving an instance of the parent and won't know that the object has the methods and attributes associated with the child class. There was a workaround though. You'd create a type var bound to the parent class, type hint the self argument to the parent class methods with this type var, which is itself pretty weird. And in the end, you can make inheritance work for this one class. This is unintuitive even for the most die-hard type hinting enthusiasts, and it's cumbersome to create a type var for each one of your classes. Enter the self type. You can now import self from the typing module, and things should just work out. You can even use self and class methods by using the built-in type function to type hint the class argument. Variadic Generics allow us to create generics, which are parametrized by an arbitrary number of types. This is implemented by a new type, typeVarTuple, along with the ability to perform tuple unpacking on typeVarTuples. Let's suppose we want to create an array object that is generic with respect to two parameters, dtype and shape. Shape itself can be of arbitrary length. We could let our class inherit from generic, parametrized over our typeVar dtype and our new typeVarTuple shape. We can use tuple unpacking to unpack our typeVarTuple into its constituent typevars. Finally, let's add some methods to our class. We can type in a 2D array by creating an array that is float int int. Here, float would be the dtype, and the remaining two ints would correspond to the arbitrary number of typevars unpacked by the typeVarTuple. Since we provided two types after our dtype argument, X is a two-dimensional array. Similarly, we can hint that an array is three-dimensional by providing three types after our dtype, shown here. We can add two types of the same dtype and shape, but if we add arrays of different shapes, a type checker will raise an error. Finally, if you work with databases, you're going to want to know about literal strings. Literal strings help distinguish between user-provided input or strings we wrote or constructed with our own source code. Here, we sketch up two queries to a user table in a database. In the first, we accept a plain user-provided string, and Little Bobby Tables strikes again, SQL injection. Or it would have if we didn't use a literal string. Our type checker could tell that our input was a plain string and not a literal string, so it raised an error. Alternatively, in the second case, we explicitly type hint our user ID as a literal string, because we wrote it and trust it. The type checker can correctly infer that the overall query is a literal string, and we can safely execute our query. There are even a few more release highlights that I didn't even cover, and there's a lot of changes down in the details. But I've covered everything that I'm actually excited about. If you want me to dive into any of these other features I didn't cover, or you'd like me to do a deep dive on anything I did, please leave a comment, like, and subscribe.